This is the Oscillations lab. So first, the introduction. The purpose was to model the motion of a spring mass system, extreme sports, using a computational model and determine if the energy remains constant in the spring mass system. So the basic models used is Newton's second law / the momentum principle, the period of oscillation formula, net force, gravitational force, and spring force formulas, and the energy principle. So a preview of the results. The energy principle is upheld. There is zero change in energy in the system. So the system versus surroundings and the forces. The system is the spring ball Earth. The surroundings are none, and the forces used to calculate the change in position / change in velocity of the system is the velocity update / position update formulas. So our initial conditions and assumptions from pre-lecture video number 52, the spring length at equilibrium with a ball 0.7 meters, the origin at the attachment point, y-axis is aligned with the spring, the frame rate in tracker is 10.53 frames per second, and the video is observed from frame 5 until the end. So the details of the experiment, the ball is released from rest at the initial position, negative 0.114, negative 0.618 meters, and the period of oscillation in the y direction was 1.5006 seconds, and you can see in the graph to the right. So here are the details of the code. First, I set it to the spring constant and the relaxed length of the spring to what was given. I then found the force of the spring. Then after that, I have the formulas for how I found the kinetic energy, gravitational potential, spring potential, and then the total energy, which is the sum of all of them. I set the mass of the ball to what was given, as well as the initial position vectors and velocity vectors, which is the initial position, and then it started at rest, so that was 0. After that, I set a while loop for how long the time was. I set the initial energy values to the original formulas from the energy, as well as the force of gravity just be negative mg, and as well as the spring constant, or the spring force, and then F net is the sum of them. The velocity and position vectors update accordingly. And then after that, to find the final velocities, I updated them from when they come out of the while loop for the kinetic, gravitational potential, and spring potential, as well as the deltas, which were just the initials that I had minus the finals at the end. And then, yeah. Here I have the energy graph. You can see that delta E overall stays at 0 throughout the whole time because there is no change in energy. You can see how each vary, delta U grav and delta U spring, so the gravitational potential and the spring potential oscillate between each other and are seen as opposites, one being like sine and cosine. And then the kinetic energy has a smaller oscillation. So here are the position graphs. You can see that the model and experiment are relatively close in the x position and have a little bit more variation in the y. And then, yeah. So sources of error and accuracy of tracker. How much is due to the problems with the video / inability to capture real motion in the y direction, which is why there is more variance in the y graph than the x graph, and not a smooth line for either real motion, must contend with drag / air resistance. So what does this mean, energy principle? Is the energy principle satisfied? The change in energy equals the work from the surroundings on the system. As seen in the graph, change in energy remains constant at 0. The Earth spring ball system leaves nothing in the surroundings, so work is 0. And then the kinetic energy plus the gravitational potential and spring potential equals 0 as well. So what does it mean, period of oscillation? The calculations taken from graphs from positions in the x, y directions. In the x direction, time is taken from 4 oscillations, and then you see the range there, and it was 6.648 seconds, and then 4t equals 6.648, so 1t equals 1.662. And the y direction, time taken for oscillation, you can see the range there was 7.503 seconds, 5t equals 7.503, and 1t would equal 1.5006. And then here for the kinetic energy, 4 pi squared times 2m divided by t squared is a higher time for a period of oscillation, which means a lower spring constant. So conclusions, is the energy principle satisfied? It is because there is no work from the surroundings. The change in energy is because the work, the computational model can predict with fair accuracy the motion of the ball spring and earth system.